construction of the M-machine. After the construction, you will see a proof of why the M-machine works. Proof. There are two cases for the proof of the M-machine. Case 1, when the x-coordinate of point C is greater than 0. If the x-coordinate of point C is greater than 0, you will have two triangles on the right-hand side. Both of these triangles will share a common angle, G. Triangle ABG and triangle FEG share a common angle, G, which means that it is congruent to both. Triangle ABG has right angle A, and triangle FEG has right angle F. Therefore, triangle ABG and triangle FEG are similar triangles by angle-angle similarity because they have two congruent angles. As long as point C is positive, if we move point A so that it is negative, the two triangles are still going to share a common angle. In this case, the common angle would be angle EGF. And they still have two congruent right angles, angle A and angle F. Now let's move to case 2. Case 2 occurs when the x-coordinate of point C is less than 0. As I move point C to a value less than 0, you can now see that the two triangles, triangle ABG and triangle FEG, don't have any angles in common. They still have two right angles. Triangle ABG has right angle A, and triangle FEG has right angle F. But in this case, segment BE and segment FA are intersecting segments, and they form congruent vertical angles. Angle BGA and angle EGF are congruent vertical angles. Therefore, triangle ABG and triangle FEG are similar triangles, once again by angle-angle similarity, because they both have, again, two congruent angles. Since segment DC and segment EF are parallel, and segment DE and segment CF are parallel, CDEF is a parallelogram, and therefore segment DC and segment EF are going to be congruent. These are congruent because in a parallelogram, opposite sides are congruent. The length of segment BA is going to be equal to 1. Regardless of where I move this segment, the value is always equal to 1. And this is true because the segment is contained or bounded by the x-axis and the line y equals 1. Since we've already claimed that these two triangles, ABG and FEG, are similar, then we have to take their characteristics, which means that they have proportional sides. The proportional sides, or the proportion that we are interested in, is GA over GF is equal to BA over EF. This means that using substitution and the information we've already gone over, that we have segment GA over segment GF, this ratio stays the same, is equal to 1, because the distance from B to A is 1, over DC. We previously stated that segment EF and segment DC were congruent, so we can substitute. And again, this gives us a proportion GA over GF equals 1 over DC. Finally, we obtained that GA times DC is equal to EF. We obtained this using cross multiplication of this proportion here. If you cross multiply, GA times DC is equal to 1 times GF, which is GF. Now GA represents the x-coordinate of point A, because that distance from here to here is 2. That will always be the x-coordinate of point A, because point G is located at the origin. Segment DC represents the x-coordinate of point C. Now DC is this vertical segment, but if you notice, DC has an endpoint on the line y equals x. So whatever my x-coordinate is, my y-coordinate is also equal to that. So DC is the x-coordinate of point C. And segment EF represents the x-coordinate of point F. And again, this is true because we're looking at EF being congruent to DC. And if it is congruent to DC, then it is congruent also to this ratio. If we take those x-coordinates, 2 times 4 equals 8. As I move point A to a different location, I still have my x-coordinate, negative 2 times 4 is equal to negative 8. If I move point C, 2 times negative 3 is equal to negative 6. And again, all of this is made possible because we have similar triangles with proportional sides. And that is what makes this M-machine work.